Welcome to our revision series. As we had started, we had looked at May 2021 and we had done question 1. As I told you, we may not do all the questions, but we do them according to the ones that are retained in the syllabus currently to be examined with effect from December. So question 2 has 3 parts. Question 2A highlights 2 properties of each of the following probability distributions. Roman 1, binomial. Roman 2, Poisson distribution. So let me try by highlighting this. Question 2A, Roman 1, binomial distribution. I can squeeze my properties here and explain. Number 1, for binomial, the distribution has only 2 mutually exclusive outcomes. That is success and failure. We use the word mutually exclusive, success and failure, because we are told to get 2. 1, the next one is the probability of success or failure remains constant during analysis. So we are only to emphasize 2. So we are saying that when we have outcomes being 2 mutually exclusive, it is success or failure. For example, when we talk about the banking sector, a customer can take a loan. There are 2 possible outcomes, either paying the loan or defaulting. Those are what we call mutually exclusive events. You either pay or you don't pay. 2, we assume that in the knowledge of that bank, the credit section, the probability of that defaulting or paying will remain constant. And that's why the bank in the insurance sector, the risk analysis, they're very particular from the past experience that what's the chance that this person is like to default or pay. That is illustration. You know, there are so many other properties of binomial, but we are asked to get 2. Many of the others can be the results are out of counts. That is 1, 2, 3, up to n. That is among them. Let's look at the other one, Poisson. Poisson distribution. This is a kind of distribution which is 1 estimated from binomial or on its own. It is a discrete probability distribution which is used to determine probabilities for rare occurrences and mainly on interval basis. So Poisson is measured by keyword the rate. Therefore, among the properties of Poisson is that we have the rate of occurrence, the average rate. So the average rate of occurrence bracket lambda remains constant during analysis. So the intervals of occurrence are non-overlapping. I'll explain that. And independent. Now, what do I mean? The rate of occurrence, for example, if we talk about restaurant, the average rate of inflow of students to cafeteria, say 10 students per minute or per hour. So we assume that for a business person, lunch time is cited that this is the annual rate. The average rate of students coming to our custom restaurant, maybe lunch hour, say the 20 per hour, so that you can have estimate of the flow of students that are arriving. Also, when you talk about intervals, because these are within the time intervals per hour, per minute, that's why you get those units of measurement. So we are saying, if, for example, we talk about interval of time between January 2021 and January 2021, December 2021, and also January 2020 to December 2020, these are what we call non-overlapping. And therefore, the interval of occurrence from January to December 2020 and the interval of occurrence January 2021 to December 2021, they are non-overlapping and are independent. For example, if we talk about the accidents occurring in a given road, what happened last year and this year, the same period, they are independent and therefore non-overlapping. That is among other properties of Poisson distribution. So we are going to move to question 2b. 2b, what does it say? 2b, I want just to highlight. I can explain this one when I say the question is enumerate 2 advantages and 2 disadvantages. Enumerate 2 advantages and 2 disadvantages of the ordinary least squares method of forecasting. Now, the first is to talk about advantages. So I can write advantage, just highlight verbally. 1, all the values can be forecasted within the given interval without omitting any, which is unlike moving average method. All the values can be forecasted using this method without omitting any value, unlike the moving average method. That is for every time interval, every time there is a forecast value. That is one advantage. The next advantage is that the equation, all estimates or forecast can be attained. 2, the model or the model gives the rate of growth least squares method, we have this as estimate a plus bx. This is the slope. The slope will give us the rate of growth, which is either an increase or a decrease. So B is the slope, while A is the intercept. So with this, we are able to get how fast is the revenue increasing as the sales also increase, rate of growth. Disadvantages we have here. What can we say as a disadvantage for that? One, if a value is added, it will distort the trend equation, which means you will have to reorganize the data again to obtain a fresh trend equation. So adding or subtracting a value distorts trend equation. Subtracting a value distorts trend equation, which means you need to revise whatever was there earlier to come up with a new trend equation. And that is what it means. Two, the model cannot be used in multivariate analysis. That is, when you have many observations taking place, you may have multiple regression equations, but there's a limitation, and therefore, if you have several spectrum of values, several areas of study, you may not use least squares method to get the accurate information. That's what we call multivariate analysis. Several spectrum, you have maybe performance, you have also the raw data, we have also the attributes in terms of maybe motivation of workers and the rest. This method will not give you the result. Therefore, we talk about multivariate analysis, and that is what it means. So those two can help us understand that as much as we have the advantage of least squares method, it has got its own disadvantages. Among them, these ones are the ones that we have. So you can, for your own studies or reference, move and dig more from other books. They'll tell you more and more of the disadvantages here. That is what we need for that. Question 2B. Next, I'll move to question 2C. This question is on decision theory. An investor intends to purchase share in one of the three companies A, B, C. The three companies have varying degrees of sensitivity to the state of economy. Those are states of nature. There are three states of the economy classified as weak, moderate, or strong. The investor has constructed the following payoff table for the profits under the three states of economy millions. The tables, the company ABC, we have weak, moderate, strong. The probabilities of the three states of the economy are 0.2, 0.4, 0.4 again for weak, moderate, and strong respectively. Required. Advise the investor of the best course of action based on the maximin. Now, let me say one thing here. When you are Roman 1, maximin, Roman 2, maximax, Roman 3, minimax regret, and Roman 4, expected value of perfect information, we need to compute those ones. Maximin is a situation whereby decision maker is pessimistic of the outcome is of the worst state. Therefore, the only strategy is to take the best out of the worst. And what do we say? You can only decide on a strategy, not on a state of nature, because strategies or decision alternatives are within the control of decision maker. Therefore, the companies are alternatives. The state of the economy are the state of nature, which are beyond the control of the decision maker. So we can only identify a company which is alternative or the decision criteria. Therefore, under maximin, question 2C, under maximin, we have to list the strategies or the companies, their worst payoff, then we select the best from the worst. So we have company, worst payoff, company A. The worst payoff there, because if you go wrong under weak, medium, moderate, and that, we have -4, 3.5, moderate, and that. So the worst is -4.0. Company B, the worst is -2.0. Company C, the worst is -2.4. So decision maker or the investor should select company B as it has the best of the worst. That is under maximin criterion. Roman 2, under maximax criterion. These are compound one. Maximin is maximum or minimum. Then maximax means the maximum of the maximum of the top of the top. Still, we follow the same procedure. We have company, best payoff, this is what I have, company A, company B, company C. Best payoff here is 6.0. Best payoff is 4.5. Best payoff here is 3.5. Because we want to get the top of the top of the best here is 6.0, which corresponds to company A. So the investor should select company A as it has the best of all payoffs. That is what we have. Minimax regret. Now, let me explain this thing of regret. Regret in decision making refers to alternative foregone. What do I get? It is always obtained as getting the difference between the actual payoff and the highest possible payoff under given state of nature. I repeat, payoff is the difference between the actual payoff obtained and the highest payoff under any given state of nature. Remember, state of nature now, the condition of the economy, moderate, and that. Therefore, we compute the payoff, the regrets in each case. Next, we have to list the maximum regret for each company. Then finally, the minimum of those maximum regrets. Whatever corresponds to a company, we select that company, and that is what the investor should do. So regrets, we compute as follows. Company, we have state of economy, weak. I've just produced a table with the regrets shown: moderate, strong, row of maximum regret. We compute the regrets for each case of the state of economy or state of nature. Under weak state of nature, we have the best there is negative 2.0. So the actual payoff here is negative 0.4. What's the regret? Is negative 2.0 minus 4.0, which should give me 2.0. I put my working as such. So that is the regret there. Next, which is B, I have negative, and C, this was corresponding to negative 2. So I have negative 2.0 minus 2.0. Regret is 0. Next is negative 2.0 minus 2.4. Regret is 0.4. Next, moderate, the highest in this case is 3.5. All the values are subtracted from 3.5. So 3.5 itself, 3.5 minus 3.5, regret is 0. 2.5 and 3.5, so I have 3.5 minus 2.5, regret is 1.0. Then I have 3.5 minus 2.8, 3.5 minus 2.8, regret is 0.7. Under strong state of economy, the highest value is 6. Therefore, regret is 6.0 minus another 6.0. That is 0. Next is 4.5. So 6.5 minus 4.5. That should give us, 6.0 is the highest. 1.5. Then 6.0 minus 3.5 should give me 2.5. Under this row of maximum regret, I have 2.0 the highest. Under this, I have 1.5 the highest. Under this, I have 2.5 the highest. So the minimax regret, minimizing maximum regret, minimum of all these is 1.5. Therefore, 1.5 corresponds to company B. So what we say here, under minimax regret, criterion, the investor should select company B as it has the list of maximum regrets. We are done for that part, and therefore, what we need here is the next is Roman 4, expected value of perfect information. Now, that is another word. Perfect information and expected value. The first thing to do is to get expected payoff for all these values under uncertainty. Then the expected payoff values under certain, which means if you now know what the future holds, you'll go for the best. So let's look at this one first of all, expected monetary values under various. So we compute Roman 3, Roman 4. Expected monetary values, which is the sum of P payoff times the probability, because we are given those probabilities for each company. For each company. So company A, EMV equals, there is a negative 0.4 because we have the probabilities are 0.2, 0.4, 0.4, and then no, for A is negative 4.0. So we get the payoff as negative 4.0 times 0.2 plus 3.5 times 0.4 plus 6.0 times 0.4 again. We get that value. I use my calculator. Which is going to give me 6 times 0.4 plus 3.5 times 0.4 again minus 4 times 0.2. This gives me 3. For B, the EMV equals expected monetary value. The lowest there is negative 2.4, negative 2.0, sorry, times 0.2 plus 2.5 times 0.4 plus 4.5 times 0.4. I get that value. Should give me 4.5 times 0.4 plus 2.5 times 0.4 minus 2 times 0.2. This one gives me 2.4. C, EMV equals, the lowest there is minus 2.4 times 0.2 plus 2.8 times 0.4 plus 3.5 times 0.4, which should get us as this. What do I get? I'll get 3.5 times 0.4 plus 2.8 times 0.4 minus 2.4 times 0.2, positive 2.04. So the highest under uncertainty is this. But we have found highest under uncertainty equals 3. So under perfect information which is certainty. You are sure what the tomorrow holds. So what do I get? I'll get these values. I have under A, the highest there is 6. So expected value is going to be 6.0 times 0.4 plus. Under B, the highest is that 4.5 times 0.4 plus the highest is 3.5 0.4. So I can find out what is my value here. 6 times 0.4 plus 4.5 times 0.4 plus 3.5 times 0.4 should give me 5.6. So let me cross check again. 6 times 0.4 plus 4.5 times 0.4 plus 3.5 times 0.4, 5.6. So expected value, that is the extra benefit this one will get if he had the prior information, would be this. Expected value of perfect information, expected value of perfect information. Value of perfect information, the difference. $5.6 minus the highest under that one, 3, which is equal to 2.6. So that is what was expected of us from that question, and that is what we have. So that is how that question 2 was supposed to be worked out, and we'll stop there and continue with the rest as we select which ones are still within the syllabus. Thank you very much.